Physics Part 405. Connecting the op-amp to the potential divider would thus change the potential differences across the components in the potential divider. However, if the op-amp connection, the input has infinite resistance, or more strictly for alternating voltages, infinite impedance, then connecting it to the potential divider will not affect the potential differences. Zero output impedance. The whole of the output voltage is seen across the load connected to the output. If the output connection had some resistance, then the voltage produced in the op-amp, the output voltage would be divided between the output and the resistor connected to the output. Zero output resistance or zero output impedance means that all of the output voltage will be seen across the resistor connected to the output. Infinite open loop gain. This means that when there is only a very small input voltage, the amplifier will saturate and the output will have the same value as the supply voltage. The voltage gain, or simply gain, of an amplifier is a measure of how many times the output voltage is greater than the input voltage. The voltage gain is equal to output voltage divided by input voltage. When there are no components connected between the output and the input of an op-amp, the gain that is measured is said to be an open loop gain. The output of an op-amp cannot be greater than the supply voltage from energy conservation, and so if a very small voltage is applied to the input and the gain is infinite, then the output will be at supply voltage. The output cannot be any greater even for a larger input signal. The amplifier is said to be saturated. Infinite bandwidth. All frequencies are amplified equally. If an alternating voltage is supplied to the input, then the output will have the same frequency but a larger amplitude. The range of the frequencies that are amplified by the same amount, the input signals of different frequencies that all have the same gain, is known as the bandwidth. Infinite slew rate. When the input signal is changed, then the input signal will also change. The slew rate is a measure of the time delay between the changes to the input and output. A high slew rate implies a short time delay. With an infinite slew rate, there is no delay. In reality, op-amps are not ideal. The input impedance is in the range 10 power raised to 6 minus 10 power raised to 12 omega, and the output impedance is about 10 power raised to 2 omega. The open loop gain is not constant, but is the order of 10 power raised to 5 for direct voltage. There is a finite bandwidth and the slew rate is about 10 voltage US power raised to minus 1. The operational amplifier as a comparator. When an op-amp is used incorporated in an electrical circuit, it is usually connected to a dual power supply so that the output voltage can be either positive or negative. Such a power supply can be represented as two sets of batteries as shown in the figure. The link between the two batteries is referred to as a 0-volt line or earth, and it provides the reference from which the voltage on the inputs and the outputs are measured. The output voltage Vout of this circuit is given. Vout is equal to A naught into V plus minus V negative, where V plus is the voltage at the non-inverting input and V negative is the voltage at the inverting input. A naught is the open loop gain of the amplifier. Consider the case where the non-inverting input V plus is 0.95 V and the inverting input V minus is 0.94 V and A naught is 10 power raised to 5. The supply voltages are so since the output voltage can never exceed the power supply voltage.